Okay, just as there's a main trick for sines and cosines, there's a main trick for secants and tangents, which begins remarkably the same way. Sine squared plus cosine squared is 1. Divide everything through by cosine squared. Because sine squared over cosine squared is tangent squared, cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. So secant squared is 1 plus tangent squared, and tangent squared is secant squared minus 1. This can be used to turn things into the good format. For example, tangent cubed, secant cubed. You can't set u equal to tangent because we'd want secant squared, and we have secant cubed, that's too many. We can't set u equal to secant because we'd need a du of tangent secant. We have too many tangents. But we can use this trick to convert most of the tangents into secants. We split it up so we have 2 tangents, 2 secants, and then the other 2. And if I can turn both of these tangents into secants, or at least secant squared minus 1, like so, and leave everything else the same, then I can set u equal to secant period. Du is secant x tangent x. Hey, there it is right there. We're left with u squared minus 1 times u squared du. And if you multiply that out, you get u to the 4th minus u squared du, and you integrate that, and you get 1/5 u to the 5th minus 1/3 u cubed. Plug back in your secant, and you're done. That's your answer. This works for a lot of other cases. If you have something like this, what are we going to do? We can turn secants into tangents here. We can turn secant to the 6th is secant squared times secant squared times secant squared. We can take 2 of the secant squareds and turn them into 1 plus tangent squareds. And then you're going to have what? Tangent to the 7th times 1 plus tangent squared times 1 plus tangent squared with 2 secants left over at the end. Set u equal to tangent, du is secant squared, you're left with a polynomial. Or even something as simple as secant to the 4th. Secant to the 4th, what do? Turn 2 of the secants into tangents, and then set u equal to tangent. I'll sketch that real quick. You can set this as, this is secant squared of x times secant squared of x dx, and secant squared is 1 plus tangent squared of x times secant squared of x dx, and all you have to do is set u equal to tangent of x, and du is secant squared of x dx, and there you are. We're left with 1 plus u squared du. And this in fact will work anytime you have secant to an even power. Secant to an even power times any number of tangents, turn all but 2 of the secants into tangents, and then this trick will work.